Imagine a messenger, a little time capsule just hurtling across the vastness of interstellar space, sent from a totally different star system and carrying all the secrets of its home. Well, today, we're going to unpack the story of one of those visitors, an object that really challenged what we thought we knew.
And that really gets to the heart of it, doesn't it? This is the central question of our little cosmic detective story. See, by studying this alien object, we're not just learning about some faraway world. We're asking a much deeper question. How common, or how unique is our own solar system?
So, let's meet our visitor, 3Is/Atlas. First spotted back in July of 2025. And get this, it's only the third interstellar object we've ever confirmed. I mean, think about that. In all of human history, this is just our third crack at studying some pristine, untouched material from a completely different stellar neighborhood. That's a huge deal.
Okay, so our investigation begins. And what's the first thing any good detective does? You get a baseline description of the suspect, right? You figure out what you're dealing with. So what did we see when we first got a look at this interstellar traveler?
And bam! Right away, the detectives got their first big surprise. Even though this thing traveled for who knows how long from another star, its color, that's what you see there with the red diamonds, fits perfectly with the comets from our own solar system. It was like finding a long-lost cosmic cousin, at least on the surface.
So, to dig a little deeper, scientists needed a more powerful tool. They decided to look at the light coming from the comet, using a technique that lets them see past the surface and really understand how it behaves.
And that tool is called the secular light curve, or SLC. The easiest way to think about it is like a comet's EKG. It's this clever graph that filters out all the noise, like how far away it is, to show us the comet's true intrinsic brightness over time. It basically reveals its vital signs.
And here it is, that EKG. At first glance, it just looks like a chaotic mess, right? A big cloud of data points. But the real story, the truth about the comet's brightness, is hidden way up there, at the very top edge of that cloud. Now, why there? Well, that's the key to this whole investigation.
Here's the logic, and it's actually pretty brilliant in its simplicity. See, anything that gets in the way of our observation, like Earth's atmosphere or maybe a not-so-great telescope, can only make a comet look fainter. It can never make it look brighter than it actually is. So to find the truth, scientists just ignore all that clutter down below and focus only on the very brightest measurements, the envelope of the data. That's where the real signal is.
And once they zeroed in on that true signal, something totally bizarre, something completely unexpected just emerged from the data. What started as a simple observation was about to turn into a genuine mystery.
This is the anomaly they found. For about 75 days, the comet's brightness took this sudden, deep, and totally unexplained nosedive. It was as if something out there in the emptiness of space just reached out and turned down a dimmer switch on it.
So, this became the million-dollar question for the whole team. What in the world could cause an object just flying through space to suddenly wink at us like this? That is not normal comet behavior. Not at all.
The most compelling theory they came up with is as surprising as it is elegant. The dimming wasn't a problem with the comet itself. It was an eclipse. Something else passed in front of it, blocking our view.
And if it was an eclipse, well, that can only mean one absolutely incredible thing. 3I/Atlas isn't alone. The evidence points to it being a binary system. We're talking two comet nuclei orbiting each other in this little cosmic dance after traveling together all the way from another star. I mean, what a stunning possibility.
So, we have a potential double comet, but what's it actually made of? The next phase of the investigation was to figure out its chemical composition, to see if what's on the inside was as surprising as its behavior on the outside.
And wow, the results were just staggering. The chemical breakdown showed something truly alien. Over 93% of the material that was boiling off this comet is pure carbon dioxide. Water and dust, which are usually the main ingredients for our comets, are barely even there.
So, to put it simply, this visitor from another star is basically just a giant, hurtling ball of dry ice. A composition like this is extremely unusual, and it tells us that it must have formed in a very, very cold place in its home system. And, just to add another layer of weirdness, it wasn't just releasing gas like a normal comet. Nope. Observations showed 3I Atlas was physically falling apart, shedding these large trails of debris and even boulder-sized chunks out into space.
Okay, so let's recap.
We have this strange, CO2-rich, possibly binary comet that's actively disintegrating. How do we make sense of all this? Well, the final step was to place it on a kind of cosmic family tree for comets.
You know how astronomers use the famous HR diagram to classify stars based on their temperature and brightness? Well, comet scientists have their own version, called the Comet Evolutionary Diagram, or CED. It plots a comet's age against its remaining lifespan, and that tells you where it came from and how it's going to evolve.
And here it is, the final piece of evidence. This is the Comet Evolutionary Diagram. After all those calculations, scientists could finally place 3I Atlas, that's the little red star you see there, on the cosmic map. The big question was, where would it land?
And the results were definitive. It landed smack dab in the middle of the Oort cloud comets. These are the most pristine, ancient, icy bodies that form way out in the coldest, farthest regions of a star system. So our visitor came from a place just like the most distant suburbs of our own solar system.
So this one single visitor, this one little cosmic detective story gave us an absolutely incredible amount of insight. And not just about the object itself, but about how comet systems might form all across the galaxy.
So what did we learn?
Well, we learned this visitor was an Oort cloud comet, but from a different star. It's very likely a binary pair, made almost entirely of dry ice. But the biggest takeaway of all, it suggests that the way comets form in our own backyard might just be the galactic standard.
And that just leaves us with this final kind of tantalizing thought. We've always wondered if the way our solar system is built is unique. But if a visitor from another star looks this familiar, it really suggests the building blocks for systems like ours might be everywhere. We may not be so alone after all, because our cosmic cousins are out there, just waiting to be discovered.